Hello, welcome to today's webinar on KEB supply and regen units. So we will tell you how to use them, what are the benefits. Yes, I am Frank Weber. I'm here together with my colleague Ethem.
Hello, my name is Ethem Demirkol. And yes, we want to show you today how to use the regenerative energy of your machines efficiently. Now we're starting with our presentation. If you have any questions, you can ask them in the chat and we will answer them after that. Today we have the topics of the application, what kind of technologies we use, system comparisons of that, how the dimension is, and which benefits and savings you have. And we have collected questions that we get from our customers typically and want to answer them in this webinar. The first question is often, where does the regenerative energy is generated and how it does come it? Normally you have a mass who is get accelerated, you have a velocity and your engine has torque. And if you want to break the mass to a velocity, then you have to break it. And in this term, you see the yellow marks, and there is the regenerative energy. It's the multiplication of the torque and the speed. And you see if you are on acceleration at the beginning, you need torque to get to the velocity. And if you want to brake, you have to take the opposite torque, and in this moment you generate power that you can supply back to the grid. You saw on the last page a travel drive, and often it's not only one axis who is coupled in a DC bus, often you have more axes. One example is an automatic storage retrieval system where you have typically a travel drive and a hoist. And if you're driving, you often take power of the system and you generate power you can share back in the system. And normally you coupling the axes that you can share the energy. If one axis needs energy and the other one generate energy, you can use the generated energy. We prepared a simulation, we can look in it. You see if the lifting is going up, the lift going up, and the travel drive is on a horizontal way, that you have in the red the energy you take down from the system, from the grid, and in green the energy you can supply back. And even if you're coupling the axes, you see now that you have energy that you can share back in the system. Even you're coupling them. On the left side, on the first 30 seconds, you have an lifting and traveling. And if you go from the 35 seconds to the end, you have that your lift going down with a mass. And you see now in the simulation that you share the green energy, the total energy on the last diagram back in the grid. Frank, you want to tell us which applications you can use our regen units?
Yes, thanks. So normally the question is, where can I use regeneration? Of course, the most applications where we get energy back from the process, from the machine, from big masses. So most energy is produced normally by hoist drives or any lift applications. Also, it's worth to use it with systems with cyclically generated braking energy. So speeding up and down, something like this. Or maybe also it's worth to use one supply and regen unit to have a central power supply for multiple drives on one common DC link. Then also we come to the active Infeed Converter. They have the possibility to make a voltage stabilization, especially if your mains are not very stable, going up and down with the voltage during the day or during some cycles. Of course, we have some test systems with loading machines for gearbox testing, engine testing, all these things. Or maybe also a simple brake resistor replacement, especially makes sense for applications in cold freeze or refrigeration area where you don't want to have extra heat energy which you have to cool back. Of course, latest also stopping or decelerating of large masses like centrifuges, shredders, and all these things. So as I mentioned before, we have different technologies. I mentioned the active Infeed Converter, or also known active front end. But also we have various solutions which are dedicated to your requirements. So at first, the most successful product of KEB in the past is the passive solution. It's called COMBIVERT R6. This is really a compact and cost-effective unit to supply and to regenerate energy for normal industrial applications. So this is a line-commutated technology and gives you an unregulated mains-dependent DC link voltage. The other product we can offer for applications is the active Infeed Converter or active front end. This device really works with active modulation on the main side and also generates really sinusoidal currents. Other benefit is that we have on the DC link a regulated and adjustable DC link voltage, which is stabilized also if the mains are going up and down sometimes. And both in common have the benefit to have a feed-in and regeneration unit, so both directions, to supply my process and to regenerate energy back to the mains. Now the question is, do I use the R6 or the active front end? So only a short overview of the use cases or normally the benefits. The COMBIVERT R6 is used in standard industrial applications where you have any kind of regenerative energy. Also for cost-effective applications because it's very compact and lightweight. And also, especially for the smaller units, it's a very easy installation, only a few adjustments. It can also work with third-party products as well as with the KEB products. The active Infeed Converter has a little bit more benefits like sinusoidal currents. So it's really reduce the harmonics a lot. And also the reactive power is nearly zero. So this means the power factor correction is included. The cosinus phi phase shift factor is 1 in the default setting. You have a stabilized DC link voltage as well as a voltage step-up converter. So especially for synchronous motors or also asynchronous drives, you have an extended speed range. With higher voltage, you have a much higher speed before coming into the field awakening range. Also, active front end can have some benefits for highly dynamic applications where you have very fast reaction times for changing between supply and regen mode. So coming to the COMBIVERT R6, a little bit more details. Compact and lightweight, we said before, with 3 different housing sizes, which can be scaled up to 1000 kVA. The pre-charge circuit is included in the housings, and especially the smaller one, the E-housing, what we have on the left side, it's usable for 200 volt grids, 3-phase, and all the others also for 400 and 480 volt mains, 50 and 60 hertz. Can be connected to nearly any DC link with KEB devices as well as some other devices. And in the end, it's an easy replacement for braking resistors, especially to reduce fire hazards. Often the question comes up for the power quality and the harmonics. So the power factor at the R6 units, which are mains commutated, is nearly the same like a standard drive controller with a mains choke. So the THDI factor, which is a sign for the harmonics, is approximately 45% with a normal standard mains choke, same like with the drive controller. And also we can offer a special harmonic filter from KEB. This gives you a THDI factor about 8% or less. Here's I have an overview for the power ranges to have an idea on the size. In the background you see a standard Euro pallet with 80 centimeters and 120 centimeters. On the left, the E housing, two sizes with 17 kilowatt and 42 kilowatt. The R housing can be used up to 140 kilowatt. And the P housing on the right is up to 330 kilowatt. And all of them can be used in up to 3 units in parallel to increase the maximum power. The active Infeed Converter can reduce the harmonics even more, typically less than 3%, both in motor power supply and during the regeneration. Stabilized DC link is one of the benefits. Active power factor correction because of the sinusoidal currents and phase shift factor of 1. We can use it for standard DC supply for some special application like test benches or charging of storages and all these things. And also with any systems with controlled energy absorption, energy storage systems like batteries, capacitors and all these things with some extra hardware around it. Power factor correction is the most liked benefit, and I come to this, what the differences are to the standard products. So reactive current and resonance phi of the active front end can be adjusted inductively or capacitive to the maximum rated current of the drive. So you can use this also as a current compensation device for external reactive current or reactive power in the grid. And THDI, thanks to the harmonic, to the sinusoidal current, is typically less than 3%. Only a short idea on the difference of cosinus phi and the power factor. Normally, when you have some grid meters, they only display you the power factor, which is typically the power factor distortion. On the left picture, you can see typically the blue is the voltage and the red curve gives you the 2 hooks for the current, which comes from the commutation. And this causes the harmonic distortion, THD or THDI of the current. For pure sinusoidal currents, this would be factor 1, otherwise you have the percentage. On the right picture, you see the phase shift factor, the cosinus phi factor. This is called the power factor displacements. But only this refers to the phase shift of the fundamental component of the voltage and the current. You see, you have sinusoidal voltage and sinusoidal current, but with a short phase shift between them, typically caused by inductive motors, which are running directly on the mains without any drive controller. This can be compensated easily, the fundamental harmonic, but not the power factor, because power factor needs some more harmonics inside to compensate. So for the dimensioning of the supply and regen units, we can calculate normally the power of the process. So normally we know the mechanical shaft power of our drive or gearbox. Then we can calculate the electrical input power of the drive controller, for example. So for the supply and regen units, the limit is always the AC phase current. This is the design point for our Infeed or regen unit. So the motor currents of the normal drive controller are not very informative for the design of the feed-in, because as Ethem explained in the beginning, you can have full torque on the drive, but very low speed only. And the power is always the factor of speed and torque. And high torque but low speed means less power. So the drive is nearly at full utilization, but not the feed-in or regen unit. So we look at the maximum occurring electrical motor power in the application. Please consider the efficiency of all drives and components in the application, which we show on the next page. So motor ratings are typically the mechanical shaft power. The electrical power is higher due to the efficiency. And one more point to consider by dimensioning is the DC link precharge. The R6 unit and the active Infeed Converter will always precharge a DC link of all connected drives. The data for this can be found in the technical documentation. So looking at the motor power we really need, as we said before, we're coming from the right side. The mechanical output power of the shaft is known. Then we have the efficiency of the motor. It can be, depending on the motor, if it's inductive motor or servo motor, normally between 0.8 or 95%, something like this. The drive itself has an efficiency of 98 or 99%. Also the active Infeed Converter, active front end, has an efficiency, and the filters on the input line. So when we calculate all these efficiency factors in the process, beginning from the shaft output of the motor or gearbox. Gearbox has also a big efficiency influence. Back to the mains transformer, for example, we can calculate all these efficiency factors. For an example, we have a 10 kilowatt motor, 10 kilowatt mechanical shaft output. Let's say we have an efficiency of 90%. Then we find out that we have an electrical motor power of 11.7 kilowatt for shaft output of 10 kilowatt only. Then we can calculate the mains current at the mains voltage tolerance. Now we calculate it at 360 volt AC, so then we need 18.8 amp at the input of the regen unit at the mains. If we go the other way around, if we have a regen or braking process, we have a braking torque on the motor, deceleration torque, which is about 10 kilowatt. Then we see, with all the efficiencies, reduce the electrical power. Then we come from 10 kilowatt shaft power down to 8.6 kilowatt. If you calculate the current for this, this would be about 13.8 amp only at 360 volt AC. So in normal processes, the regenerated energy is always much less than the input power for the process. Of course, when you have a storage retrieval system, there are some more efficiency factors like ropes and rails and all these things which has to be considered. But you can say, for example, in a storage retrieval system, approximately 60 to 70% of the motor power can come back as regen power, which we had also on the former pages by Ethem, which we have the multiple axis view. Anyway, if there are questions for dimensioning, please give us a call, an email. We can help you with this. So now, Ethem, maybe you can tell us how to save really energy cost.
Yeah, often we get the question, yeah, I'm not an energy provider. How can I get money back of the system? And to be fair, you don't share the energy you get back from generation back in the grid. You share it in your system. That means if you have regenerative energy, you share it back in the system, like for lamps, for your IT infrastructure, for other electrical machines, and not back to your system. And because you don't share it back to as an energy provider, you don't get more energy of the grid. That means you use the energy totally from your system, and only the energy you need after that you take from the grid. And because of you don't take it out of the grid, you don't have to pay money for it. And now you can save energy. You can save money with the energy you regenerate. Now the question: how much money can I make from it, and how much energy I save? Yeah, the question is easily answered. You have to look on the time load. How often and how long is my machines used? Of course, you need the electrical price. With that information, how often you use the machine, how long you use it, which price you pay for the electricity, which masses you have to break, you can calculate the energy costs. And if you look, your braking resistor costs like 40 or 50% of the regen unit. But with the time, you get the energy paid you share in your system. And in this example, you see after 24 months, you have the price out from the regen unit. And after that 24 months, you make money with it. Yeah.
Okay, this looks interesting. Shows us that it's worth to use energy regeneration. Can be paid with less than 24 months. This is what we always see in most applications. Yes, and interesting. So now we see there are many questions.
Yes, exactly. Yeah, we collected many questions of our customers that we get typically. One of them is, what happens in the event of a power failure? Frank, you can answer that.
So yes, of course, if the grid is powered off, or if there's a blackout, we cannot regenerate energy to the mains. But the question is, what would do the other option, the braking resistor? If you are just in the operation of deceleration, then it can help. But at least if the deceleration is stopped, then the drive will shut off because there's no energy. And so normally there's not a big difference if you are talking about a brake resistor, which is typically used and known as a proved concept, but also the regen unit. Okay, if the power is gone, also the brake resistor will typically not help to have your process alive, if you're not only just in the case of deceleration.
Yes. And one other question is, we talked about that we coupling many axes in the DC link, in the DC bus. Mm-hmm. And one of the main questions is, can we do that without DC fuses?
The fuses really give you some extra safety because it's not only the cable damage or fire protection for the cables. This can also save about breaking the units. So all our units are tested in a safe environment, and the standard tests for certification are done with fuses. So we really recommend to use DC fuses in this case.
Yes, another question is, often the systems are already engineered. How easily or is it possible to integrate our R6 or active Infeed Converter in systems that already exist?
So in the standard case, we use the regen unit as an infeed and regen unit. So we only change the input line with the R6. We put the R6, for example, in the input line of the inverter and supply the standard drive controller not only with the AC line but with the DC line. So the inverter or the DC link, which is existing, needs to have an connection for the DC of our R6, for example. The R6 is available with integrated fuses, for example, and then you only have shut off the normal AC connection point and make the feed in with the DC with the regen unit. So on the other hand, of course, you can use, especially the R6, can be used for regen mode only. Then you only install some simple decoupling diodes. Then it's possible to use it as well.
Yeah. Another question is it possible to take the system parallel?
Yes, the R6 units can be switched in parallel. They are synchronizing each other on their level. And not only in the small synchronization unit or synchronization input. For the active Infeed Converter, it's a little bit more complicated. We can do it with a special controller on top, but there we have a variety of power dimensions. So nearly the active Infeed Converter is available in all power stages.
Levels.
From very small, I think the minimum is 11 kVA, goes up to 1000 kVA. So there's a dedicated one which can be used for every power range.
Yeah. The last question is, can we connect storage in the system with an R6 or an active Infeed Converter?
Yes, this is always asked. There are modern systems with, let's say, supercaps or batteries. This can be driven especially with the active Infeed Converters, which have the special function for the current limitation on the mains and the control to DC link. The R6 is normally not recommended to use with batteries or with capacitor storages, but also a good option would be kinetic storages, where you can control the inertia of a special storage, kinetic storage, speeding up and down to generate energy on the DC link. Yes, so in the end, we have a solution for storages, depending on the size, if it's batteries or caps or kinetic storages, but normally we use active Infeed Converters for this.
Perfect. That were the questions. Now we come to the end and sum up the advantages of a regen and supply unit. Of course, one of them is that you don't have heat on braking resistors if you use a regen unit, because you can take the energy back to the grid. It's environmental friendly. You use the regenerative energy and don't heat it up. You save costs. It's simply wired and easily installed. You have an extended speed range and torque range in the feed weakening. And in the total, you have an efficient system.
And it helps to make the environmental savings make it a little bit more friendly.
Exactly.
Thank you for today's webinar.
We hope you enjoy it.
Please send us your questions. We can answer them and help you with dimensioning, choosing the right system for you.
See you next time.
Bye.